Wireless charging technology used in smart devices. We will start with WPC, Wireless Power Consortium. This was established in December of 2008, and it has the objectives of to create a universal wireless power charging standard that can enable various mobile electronic devices to be placed on top of a single power transfer pad. And the technology was magnetic induction charging. This uses the Qi standard, and the Qi standard is the Qi, which comes from the Chinese letter that means natural energy. The WPC standard for inductive electrical power transfer over distances up to 4 centimeters. The Qi system has a power transmission pad as well as the power receiver, which is your smartphone. The Qi has a low power standard, which is the baseline power profile that can transfer up to 5 watts. Then it has the medium power standard, which is the extended power profile that can transfer up to 15 watts. The PMA, Power Matters Alliance. This is a global nonprofit industry organization that was founded by Procter & Gamble and PowerMat Technologies in 2012. The characteristics include inductive coupling, digital transceiver communication, and cloud-based power management. Alliance for Wireless Power, A4WP, was founded in 2012. It developed the Resonance standard, which has this logo right here. This is an interface standard for wireless electrical power transfer that is based on magnetic resonance. And you can see that resonance somewhat is similar to the word resonance. Power transfer up to 50 watts, a significant power level, with a distance up to 5 centimeters. The Air-Fuel Alliance was founded by the merger of the A4WP and the PMA in 2015. Both characteristics of the A4WP and PMA were joined into one overall standard by the Air-Fuel Alliance, which uses this logo. This developed Air-Fuel Resonant and Air-Fuel RF for wireless charging technologies. The basic that you will see is that because of the two standards that merged, you have inductive versus resonant technology all combined into one air-fuel standard. So therefore, there are two modes that you need to consider, the inductive and the resonant, which we will talk about now in this table. Inductive and resonant. First, looking at the standardization. For inductive, there's the WPC and the PMA. But the PMA was a part of the merger that is now the Air-Fuel Alliance. Then the resonant is the A4WP, which was also included in the merger of the Air-Fuel Alliance. Now looking into the power transmission characteristics that are used in charging. For inductive, this ranges from 100 kHz to about 300 kHz, based upon the standards of the WPC or PMA. For resonant, you can see that it is at a higher frequency at 6.78 MHz, and that is based on the A4WP standards. This is for charging. But when you go into power control that requires communication, then for inductive, this uses in-band packet communication, which means that within this frequency range, we are going to exchange packets. However, for resonant, this uses Bluetooth Low Energy, BLE standard, that communicates control packets at the 2.4 GHz range. Because the power transmission frequency is not used for the power control communication mode, we call this outband. Then, the characteristics of inductive are compliant with Qi and PMA, and for resonant, this is compliant with resonance. You can see that the characteristics of multiple device charging and free positioning are some of the representative characteristics of resonant technology. These are the references that I use, and I recommend them to you. Thank you.